All right. Hello, everyone, and welcome for this session. We're here to talk today about, let's say, two of my favorite tools, k0smotron and ArgoCD. And what I'd like to show here is how you can use both of them to manage your cluster lifecycle and your applications during the deployment cycles, upgrades, and so on and so forth. So my name is Rachid Zarouali. I'm a cloud observability architect. Basically, I'm doing a lot of stuff around Kubernetes also, obviously, but open telemetry and so on and so forth. Working right now to build a fully open source observability stack for one of my clients. And let's go. So the main point of those two tools, k0smotron and ArgoCD, is multi-cluster management. Basically, how you can easily manage not one cluster, too easy, but let's say 10, 20, 30, hundreds, thousands, why not? What we learned so far is that depending on the number of clusters that you have to manage, it could get a little bit tricky, especially because each nodes were considered as virtual machine or bare metal, and then you have to manage each cluster on their own. No real or let's say no simple central management mechanism. When you think about multi-cloud, it gets also a little bit tricky. So those tools are here, in my point of view, to help us about this pain. k0smotron, in a very nutshell, in a very couple of words, basically what we want to offer here, or what the open source team at Mirantis wants to offer, is a central cluster management solution for any infrastructure. Wherever your cluster lives, you can get it managed by this tool. AWS, Azure, Google, OVH, DigitalOcean, wherever. Aside of that, the tool aims to offer a simple, homogeneous management mechanism, meaning that you will manage all your clusters the same way, without thinking about where the cluster has been deployed, why, is there some specification about this managed cluster, and so on and so forth. The plan is also to allow HA by using external managed database. In this case, it's a Postgres SQL that you can use by using KINE, K-I-N-E, which allows to replace etcd with the PostgreSQL operator. So basically how it works, to put it simply, it's Kubernetes in Kubernetes that lives as a pod. The control plane for your Kubernetes clusters will live as pod in a central management cluster. Everything is managed using declarative API based on the K8s Kubernetes distribution that you probably already have heard or used or even deployed in production. And what k0smotron wants to address here is, let's say, a broader range of scenarios, edge computing, multi-cloud, hybridation, really offering the way to have almost a fully portable Kubernetes platform that you can move from an end to another. So what are we doing, let's say, without k0smotron? We need this management cluster, and this is a full-fledged management cluster with the control plane, 3 nodes, and the workers, 3 to 5. So what we can see here in this slide is with a single management cluster and a single workload cluster, we still have a lot of nodes to manage, not only in the deployment stage, but also during upgrades, outage, management, logging, observability, and so on and so forth. Using k0smotron, you ditch most part of the management cluster, or said differently, the control plane will live as pod. Less nodes to manage, easier to manage, easier to upgrade. And again, as you are allowed to use k0smotron to manage, let's say, a lot of clusters the same way, you can also upgrade them automatically the same way without having to connect to each and any of them. We have an example here where we use this central management cluster with AWS and Edsna, and this central management cluster runs the control plane internally and gets the management from the node that lives in AWS and in Edsna. This is a perfect opportunity to also offer some kind of hybridation when you don't want to have the control plane and the worker nodes in the same environment, in the same hoster, and so on and so forth. Underneath how it goes, we have our management cluster. We have this k0smotron controller. This k0smotron controller manages the KOS control plane, and this control plane, again, is pod. A pod, a volume, a service, and using a load balancer, connects to the worker nodes that are either in the same environment or probably in an external one, and manage the whole deployment. As simple as that. There's no, you don't need to deploy a very specific tooling on top of it. It's just a plain Kubernetes cluster where you need this k0smotron controller, and you can easily achieve that by moving your existing control plane into pods. A lot of use cases are that can be leveraged here. Again, CI, end-to-end testing, edge, when you have a lot of very small clusters that are spread across the globe, very easy to manage them. Multi-tenancy, multi-cloud, also hybridation, portability, everything can also be managed, again, fully declaratively by using GitOps. We have a demo for that in a couple of minutes. We know how k0smotron, let's say, behaves. What is k0smotron, what it offers? We still have one question now to answer, is how we are able to deploy 10, 100, or perhaps thousands of clusters at once and not manually. Even though you can integrate the existing cluster into an existing k0smotron management cluster, there's also the need to be able to leverage k0smotron to deploy tons of clusters at once and then have this automatically configured central management system. This is where ClusterAPI comes in help. Basically, the ClusterAPI is a mean to deploy at once by using Kubernetes objects, by leveraging Kubernetes and operators that connects to APIs, as many clusters as you want, as long as you have the resources available. Could be, again, 10, 20, 100, thousands, wherever. What is interesting with this ClusterAPI Kubernetes sub-projects is, again, most of the existing managed Kubernetes platform and hosters are supported out of the box. What that means is that you can deploy your own Kubernetes cluster, deploy the ClusterAPI tooling, leverage it, learn how to use it, and deploy your Kubernetes clusters not only in a single endpoint, that could be AWS, that could be GCP, that could be Azure, but all at once. You just have to create those declarations, to create also the configuration, push them into the appropriate provider, and the ClusterAPI will do the job. As simple as that. To go a little bit more in the details, we are this DevOps engineer that's on the left. We are creating. We also see later on that we can have some templates, but we had to generate several specifications, and those specifications are needed for the ClusterAPI operator and the provider operators to deploy and manage your clusters. What's interesting here, again, is everything is built on top of Kubernetes. You know how to deploy Kubernetes, you know how to manage Kubernetes, you know how to run your applications in Kubernetes, you're good. Or kind of. You still have to learn how the ClusterAPI works. And to be completely honest with you all, it's still a young project, very powerful, definitely usable in production, no worries. But it evolved quite fast, and well, as all young and very promising projects, sometimes there are some breakage. So just be cautious about this. So how can we mix them now? We have k0smotron. We have this central management solution that moves your control plane nodes into pods. And we have the ClusterAPI, also often named CAPI, to deploy at once by leveraging Kubernetes plane objects, as many Kubernetes as we want. Again, there's a lot of magic in here, but let's say nothing really complex in here. The same management cluster with the k0smotron controller, we are now adding aside of it the ClusterAPI controller and the provider or providers that we want to use, depending on if you want to deploy into a single endpoint or in multiple endpoints at once. Again, what we do is we push the declarative configuration into this management cluster, and we somehow, let's say, spread the configuration between the k0smotron controller, which will be responsible to spin up the control plane for the new cluster that we want to leverage, and the ClusterAPI configuration that will be responsible to deploy the workers wherever you want, and afterwards to deploy your application again on top of it. A very quick example that I robbed swiftly from my Mirantis friends is how they use k0smotron and the CAPI provider, which is for AWS, on how you can leverage both of them. This is what you have in those VS Code, let's say, snippets that you have here. Here is the plain definition that leverages k0smotron and the control plane by using this component that we have here, the k0smotron or k0smotron control plane. And we have on the right what defines the nodes, the workers, where your application lives. Again, not that complex. Still needs a little bit of work, but fairly easy to dig in. I'm done with the slides. So this is my kind cluster Kubernetes in Docker. So it means that I have Docker that runs here. I have a simple control plane and a couple of things that we'll discover. So demo one would be to use the ClusterAPI mechanism with the CAPD provider. CAPD is the Docker ClusterAPI provider used for development or demo. Don't use it in production. This is my very shiny YAML. And as you can see, I'm defining here the Q8m config template, the cluster. I'm also defining the cluster class, which is an object that allows me to create some kind of a template of clusters that can be used elsewhere. We have, let's go a little bit deeper. There we are. We have the Docker cluster template that defines that I want to leverage Docker to deploy my pods. Obviously, giving a name, certificates, CRDs, and so on and so forth. And in the end, I'm just defining that I want 3 nodes. So let's apply this one. Very simply, kubectl apply my cluster. So far, so good. Kubectl get cluster. Sorry, this is my cluster. It says provisioned. Kind of. Cluster, and let's use this one. And let's go a little bit deeper. So what do we have here? I have my cluster definition, I have my control plane, and I have my node. And as you can see, my control plane is simply based on one node. So if I look at Docker, because Docker, let's say, simulates the real nodes that I would want to have in my environment, I have here the load balancer for the API. I have here the control plane definition, and I have my workers. I'm good to go. If I really want to go deep in, let's say I want to get the cluster definition to show you, and let's do this. So now I'm getting the kubeconfig file. There we are. Let's do this. My cluster kubeconfig. Let's do cluster info. kubectl cluster info. My cluster is running. If I do kubectl get PO, this is my cluster deployed using ClusterAPI with the CAPI provider locally. That simulates a full-fledged cluster. All right, and again, as nodes, I have my control plane and my worker here, meaning I still have the same way of using, let's say, common virtual machine. Let's move to k0smotron now. Let's do some cleanup also. Delete cluster, my cluster dash and ArgoCD. Yes, because, all right, let's do some cleanup. Okay. So let's switch to k0smotron. If I switch to k0smotron and look at the file, I split them. I created them separately so that we can see some differences. Now I have this k0smotron control plane and this k0s worker configuration. This is what defines that the control plane will be pushed into pod and no nodes. And this defines that, and also elsewhere, that my cluster will be using, for now, let's say, the k0s Kubernetes distribution. And I can go the same way. Just apply it locally. So far, so good. Let's look how the cluster is. It says provisioned. Let's see if I can get more information. It says pending. Will take a couple of minutes to finish. And I have my load balancer that come up. So what we'll do, let's see if I can do something like this. Dash N3. All right, this one is pending. Can I do this? Yes, I can do this. Get PO, I'm there. Let's look at the logs. Kubectl logs dash n CAPI system. And let's see what the log says. All right, it's waiting for the control plane to be initialized. Let's have a look. Where is my control plane? My control plane is here. I have my KMC for my cluster. This is my API server, and this is etcd. And as you can see, living in pods. So let's see now what k0smotron provider says. Logs dash n k0smotron. And look at this one. Waiting for provider. Reconciling. Okay. And what is it saying? Running. 2 minutes. 2 minutes. Very, very simple. Again, k0smotron and ClusterAPI cluster deployed. So what we did now, so far, is we deployed only one. Let's play. How about we deploy multiple clusters at once? Let's get the cluster. Let's again clean up. So I played a little bit, and this time I created a Helm chart. A little bit, let's say, tricky. Here's the template. Basically, what I'm doing is I'm looping into my value file, and I'm looping into this file and then creating as many clusters as I want. So I just used the same configuration as before, using the same object that I wanted. So I still have my cluster, and I still have below my K0s control plane. I'm just playing with Helm to make it a little bit funny. If I look at my value file, there we go. What I'm saying 2 clusters, 1 worker, 1 controller, a version which is, oh, let's play. Let's do this. Oh, you'll see afterwards why. And I will just, let's see. Right. Let's do this. Helm install. Let's do it the other way around. Oopsie. There we are. Let's go into details and install. All right. Says deployed, Helm list. This is where it is. Okay. kubectl get cluster. I have my 2 cluster provision definition. Let's see if I already have my control plane. I have this weird behavior where it needs a couple of restarts to make it work correctly. To be honest, I don't know why. Should probably open an issue on the product for that, but no worries. Trust me, they will be good. They will be good, and then we'll see how it goes. Waiting for the both control plane to be ready. Let's see if we can get more information about the overall. Yep. And see Docker machine. They are pending. Oh, good. They are obviously pending because here they are not ready yet. Are we good to go? We're good to go. Let's see how it goes. It says provisioning, and in 1 or 2 minutes, both clusters will be fine. Again, I'm having the control plane that lives as pod. Here's my first cluster, and the second, sorry. And here's the first one. And I'm just deploying here the worker side, and that's it. And the worker side, obviously, in my case, lives in Docker because I'm leveraging CAPI. So let's wait a little bit. What we will try to see if we have a couple of minutes. All right, there we have the first node ready and the second, and there we are. And so now I can do exactly the same as before. If I do cluster, and if I do get kubeconfig, I can just, let's get this one. All right, kubeconfig, k0smotron, get PO. It's coming up. Again, as I said, it will take a couple of times to be fully ready. So we now have a simple mean to deploy multiple clusters at once. But as you have seen so far, we have a lot of manual operation. This is where ArgoCD will help us. And what I built here, and then we'll switch here. So I built a project defining a different type of clusters that you have here, the dev environment, the test environment, and the prod environment. I have my upsets. So this defines how I want ArgoCD with my k0smotron and ClusterAPI CAPI provider to deploy my whole clusters. And I'm just passing some values that you see here to a Helm chart that lives here. And the Helm charts is the exact, or kind of, that you have seen so far. I'm still looping in the same way as before, and I'm still using the same mechanism with the same values. Basically, I'm switching the Helm chart from a manual point of view to a GitOps way, fully from Git, connected to ArgoCD to deploy my cluster. And if you don't trust me, because you are allowed to, let me show you how it goes. All right, let's delete those clusters because we'll have kind of few. Come on, buddy. All right. Get cluster. Let's see if I still have some nodes all cleaned up. All right. Let's switch to ArgoCD. I will simply go into my project definition and I will just switch the branch from no demo to demo 1, which is not really demo 1, should be demo 4, but anyway. And there we go. I have my cluster application set and an application. I'll show you briefly afterwards how it goes. And as you can see, 1, 2, 3. In this definition, let's zoom out a little bit. It's a bit too much. As you can see, my cluster is spinning up. So these are my stateful sets where I'm deploying here the control plane as pod. And what you see here is a machine deployment leveraging the CAPI provider to deploy the, let's say, node-like in Docker. Again, will take a couple of minutes. What I wanted to show you, and so to let it working, is if I get back to the CLI and do something like kubectl get PO, you see that I have dev1, prod1, test1. My 3 clusters. Again, I still have this weird issue, but as you can see, it fixed it up himself. So I have my 3 clusters control plane deployed via ArgoCD into my environment. And if I look at Docker, because Docker simulates my nodes, I have my nodes, one here, and the other should be here in a couple of seconds. Let's them coming. Here's the first one, and here are the 2 others that you have here. This is where we have to pray the demo gods. This is where sometimes it's not working all good, and sometimes it goes perfectly. But the first one is ready. Let's wait a couple of seconds for the others. And if not, then we'll just move to the next step. Are they already? Yes, they are already. Do I have some weird logs? This one is dev. I'm having some weird logs. Test prod, it waits for the others. Okay, the secret has been created for the test, so they should be here any minute soon. Yeah, they are provisioning. Now, how about upgrading? The upgrade goes as simple as, again, GitOps, going into my project. Let's play for the one that works. I think that's the dev one. All right. So the dev one is, I think it's this one. Upgrading is simply doing this. 128.12, I guess. And let's go here and let's do Cosmo 1 version bump to 1.28.12. Commit and push. Okay. We are at the Cosmo 1. Let's do a little bit of refresh and see if we see something going on. We see that it got the value. Okay. Let's refresh manually. And boom, there we are. Upgrade has been triggered here, as you can see. And if I look at the details, I should be able to show you that. There we are. The upgrade has been triggered. Again, no kubectl, no manual thing. Just commit into my repository, and that's it. The final thing that I wanted to show you regarding this lifecycle, and we'll let the cluster running. I prepared a little bit of a simple app. Well, basically, it's the guestbook. Simple as that. The only thing that I said is you will deploy this application wherever the cluster match this label. Obviously, I have prepared it. This is where it lives. So I will enable this, and I will also enable this. If we have a couple of minutes left, I will explain this one. Either way, if not, just to put it simply, I'm using a CAPI to Argo controller that integrates that, register my clusters into Argo. And I'm using this trick, let's say that way, to get this label into the cluster secret so that ArgoCD can leverage it and deploy the app. And let's do enable sample app on dev. And we are close to be finished, so that's cool. And let's refresh the whole thing. Bring me my app. I said, bring me my app. Why my cluster not running? Let's refresh this one and see where it goes. I know why. All right. Anyway, yeah. Let me explain. This is my clusters. This is where they are. This secret is generated once the cluster is registered into ArgoCD, and for whatever the reason, the secret is not updated by the controller. So if I want to demo this, I will then need to destroy the cluster and replace it. But I think we are a little bit short on time. So let's wait just a couple of seconds to see if we can get some black magic. But yeah, I don't think it will go this way anyway. So you will have just to trust me into this one. Basically, the overall idea, to give you some hints, is to create your application set with your application, get the generator with the selector to match a level. Here I'm using environment dev, simple as that. I'm defining where The manifest lives exactly where this is here, apps guestbook deployment, and this is the demo app. Simple as that. And you just have to enable then the value into the cluster, deploy the cluster, and then the app will go with it. And then I will just have to thank you all for joining this session, hoping you liked this session and that I wasn't too fast into showing and demoing and explaining. If you have any question, then please, again, reach out on LinkedIn and on Twitter, wherever. It was my pleasure to be here. Hoping, again, everybody liked it. And if there's any question, either reach out physically, wherever we cross the roads, or wherever on Twitter, LinkedIn, whatever. Just reach out. And yeah, thanks for joining.